Este evento es organizado por Línea México, la Liga Nacional de Estudiantes de Arquitectura, una organización sin fines de lucro dedicada a organizar todo tipo de actividades que permitan a los estudiantes aprender un poco más de lo que enseña la escuela. Estamos en 30 estados, en más de 65 facultades del país. Somos más de 700 miembros. Y pues bueno, el objetivo es hacer todo esto con el único fin de aprender, de ser mejores estudiantes y de ser egresados con un perfil mucho mejor preparado. El día de hoy tenemos a un gran invitado, una verdadera leyenda del diseño computacional, Arturo Tedeschi. Me voy a permitir presentarlo. Su semblanza está en inglés, a partir de este momento vamos a hablar en inglés. Entonces, Arturo Tedeschi is an architect and computational design specialist with more than 10 years of experience in avant-garde segment of architecture and industrial design, furniture, automotive installations, products, footwear. He works as consultant for leading companies providing services and training related to algorithmic modeling, complex geometry, digital fabrication, and data-driven design. He's the author of Parametric Architecture with Grasshopper and AAD Algorithms Aided Design. He taught and was an invited speaker at Architectural Association, Politecnico di Milano, IUAV in Venice, the University of Sydney, Dubai Institute of Design and Innovation, University of Edinburgh, Universidad Europea de Madrid. His personal work has been featured in international magazines, Forbes, Wired, Design, and exhibited worldwide. He has collaborated also with major architecture and design firms, including Zaha Hadid Architects and Ross Lovegrove Studio. Feel very welcome, Arturo Tedeschi. We're truly honored to have you here. And also with him is Giancarlo Di Marco. His bio is in Spanish, so I'm going to change this. I'm going to start speaking in Spanish. Es un especialista académico e investigador en diseño 3D, diseño paramétrico, fabricación digital, profesor de diseño, cine y televisión en Ciudad de México, autor del libro Simplified Complexity Method for Advanced NURBS Modeling with Rhinoceros, consultor de CAD y BIM, arquitectura, diseño e ingeniería, consultor en innovación de procesos y productos, diseño industrial, diseño de productos, certificado de McNeil y Autodesk Revit Architecture, y añadiría también un gran amigo. Y bienvenido, Giancarlo. Welcome, Arturo. For me, it's more like you guys wrote the Bible for Rhino and the Bible for Grasshopper. I feel really, really honored to have you both here at the same time. It's wonderful to have you here. So feel very welcome, and the microphones are yours.
Thank you, really, thank you so much for this amazing introduction, and thanks for, it's a great pleasure to have your attention today. And also, I'm very happy to be in this virtual desk with Giancarlo here. And there is a coincidence, Giancarlo, because behind me, there is a sculpture. We actually met the first time in Rome where I exhibited this sculpture the first time. Do you remember? Giancarlo, oh, okay. There is a problem with probably with your microphone.
Yeah. Okay. No,
okay.
I just gonna turn the microphone.
Okay.
So, yeah.
Cool.
But yeah, I do remember that. Yeah, of course. In the Chiostro del Bramante, of course.
Chiostro del Bramante in Rome. Yeah, that's a nice coincidence. You know, like 10 years later.
Yeah.
Well, yeah. Again, thank you. It's a great pleasure for me to. I want to share with you guys my experience as a computational designer. Computational design is a kind of new expression. Is also, to me, it really looks like a new profession, actually, that probably doesn't have a specific place in academia in a way, but to me, it's actually it's kind of beginning and becoming actually a real new profession. And to me, it's a kind of key, and it was a key for a fluidification between different genres, different companies and industries. And today I want to share my experience, and the presentation is about this concept of multidisciplinary, because I started as an architect in 2005. But actually, after I got into algorithms and algorithmic thinking, I had this privilege to work for different industries. So before getting started, but the introduction was absolutely correct and very precise actually, but just to spend some word on my office, we tried like since 2009 to in a way to redefine the idea of consulting, because we basically work as consultants for other companies in the avant-garde segments of architecture and industrial design, and we really tried to push the boundaries and the concept in a way of algorithmic thinking in architecture, automotive, products, footwear. We really like dive into different industries, and I was not prepared when I started actually, but that's the presentation I'm going to show you. It's about how being a computational designer can give you this kind of magic key to open different doors in different industries. And actually, we currently we provide services related to algorithmic modeling, development of complex geometries in general, shape optimization, digital fabrication, data-driven design. So many aspects and different layers and that we try to investigate. And our vision is always about using algorithms in order to, there is a kind of subtitle that I always use, which is we try to seek beauty through technology. We are Italian, and in a way we are always connected with this idea of beauty, which is a kind of ghost word. You cannot really describe it. Everyone has a kind of different vision and idea of beauty, but I'm always like driven by this idea of using technology as a tool or as a system in order to improve what we are going to do in general. So let me share, please let me know if I think that currently I cannot share my screen. Probably I need a kind of authorization in order to do that.
It's okay now. Could you please
okay. Okay, that's cool. Here we go. So please let me know if you see the screen.
Yes,
okay, cool. Well, yeah, this presentation, the title is, as I mentioned before, is Crossing Disciplines with Computational Tools and Methodologies. I kind of feel entitled of speaking about multidisciplinarity because as you can see in this like super quick set of slides, we really work in totally different industries and environments, from furniture to installation to automotive, footwear. And as I mentioned before, we collaborated with several designers or companies in order to realize projects that are every time like unique pieces. It's a kind of fil rouge or leitmotif that we can say that we always had during different projects. Or for example, as you can see here, automotive or transportation, you can see build projects, advanced concepts, and sometimes also virtual design, or projects like a stadium or a development for earphones, different scale, different complexity, but again, a kind of fil rouge, a kind of common thread, which is the use of advanced tools for design and architecture. I want to tell you something. Every time we talk about tools, I think that you can distinguish between two like different approaches. As you can see on the screen, we have two slides, two images. On the right side, you can see Michael Jackson and Quincy Jones. And why I'm talking about that? Because you can interpret, you can imagine or consider computational design and the work of a computational designer like a music producer. So we are not just music engineer, the slide that you can see on the left side. I mean, we go over the main or the basic use of tools or instruments of technology, but it's always important for a computational designer to be contaminated by different influences. So you are not just a technical expert, but you need to have different references. You need to have a kind of design culture, which is not only being able to use the tool. For me, it's always important to point out this kind of difference, because we always try to be music producer, not just like music engineers. Here, another example, Brian Eno and you too. It's always also you have fun by changing sharing different instruments and tries different tools and being contaminated by the expertise of other people. Every time we collaborate with a new designer or with a new architect or company, we always try to absorb the differences, and sometimes we go in new territories and we are scared of, and we are scared about being in contact with technologies or ideas which are totally different from our main knowledge. But that's also the interesting point. And I was talking about a kind of common thread, which is computational design. It's difficult, it's very difficult to describe what a computational design is, but I want to show you something. When I was a kid, I was lucky enough to receive a Commodore 64 that was a kind of really primitive personal computer. I don't know if someone reminds this kind of console. Was super basic, and actually the language that you used to in order to create programs was called BASIC. And I remember I didn't like to play with video games, also because they were not that exciting on that computer, but I really liked to do simple programs using the BASIC language. And immediately I wanted to sketch something to create not only basic programs based on text and whatever, but the idea of creating drawings with the computer. So I came across to the Commodore 64 manual, and I spent a lot of time in order to figure out how to create images with that. And so I basically realized that you had a grid of pixels. I know that it's unbelievable, but they were about 40 per 25. So the resolution was absolutely unbelievable if you think about the resolution that we have today on a smartphone, for example. And if you wanted to create a drawing, like the thing that you can see on the screen that can be imagined like a man with the hands raised like that, you just have to take note about the pixel label, the indices about every pixel. You took note, like the set of numbers that you can see below, like 99, 117, and so on. And basically, I realized when I was a kid, I was more or less 8, 9 years old, that you could translate images into a set of numbers. So when you can do something like that, you can transfer those numbers in different ways. At that time in Italy, we had this kind of phone, and I had a friend of mine with the same computer, and we used to do this kind of play, like sharing by this phone numbers in order to translate those numbers into drawings. So we started to share drawings by the telephone. There was no internet, of course. We are talking about 85, 86, more or less. This is an original drawing of that period. I want to say I was a normal guy. I played soccer like everyone, but I also like to do something like that. This is an original drawing of that period. And the nice thing is that, let's say 30 years later, I was doing the same play and I'm doing the same game. This is a project that we developed for the Salone del Mobile, which is one of the, probably the most important design fair all over the world, in Milano in 2017. And I realized that in order to create a piece of furniture, this is a wall system that is called Sistema Fessura. Fessura in English means slot, is a little window, let's say. And I designed this object in Milano, and it was manufactured in southern Italy. We never met the manufacturer, and basically we translated this object into numbers, as you can see here. This is the final product, and it was manufactured using numbers, basically. So I didn't use the phone as I was doing in 85. Of course, we are using like technologies like the internet, or but basically using an STL. Of course, you guys know what an STL is. It's the way to convert a geometry into a set of points, and each point is a set of 3 coordinates. So you can translate shapes into numbers. Where you have numbers, they can be sent all over the world. It's very easy to translate into different things. You can visualize, you can display them as digital objects, or you can convert them into physical ones. And that's nice because data, in a way, is the common thread when you are dealing with computational design. It's important to have this kind of abstraction in order to work with data, to work with numbers in a way, not only numbers, but data in general. But as I was saying before, it's not only about tools and about numbers. If you want to be a computational designer, you should be like a music producer in the music industry. So it's about contamination. It's about to also steal from different industries, or in this case, from different arts. Sistema Fessura comes from the cut paintings from Lucio Fontana. The main reference was that. Also that the actual technology, you know, Fontana used this kind of box behind the painting in order to enhance the three-dimensionality of the object. So basically we did the same. If you take a look here, we use also a kind of black box behind the main sculpture that was created using a solid surface material like Corian, you know, or this was actually LG Max, but basically it's a solid surface material. And we started from a painting. We started, you know, the Italian tradition of futurism and etc. But the idea was to translate a painting into a three-dimensional sculpture using data. And everything anyway started from a sketch. As you can see here, we started with a very rough translation of what I had in my mind, but it's also important to check this sketch, because in general you can have two kinds of approaches when you create a three-dimensional and complex shape. Basically, you can work in a kind of abstraction like this. You already have in mind the idea, so you can just use a pencil in order to fix on a piece of paper your ideas as a kind of rough scribble, or as we also did, you can also sketch an algorithm. For this specific object, without going in depth in the definition that you can see here, we actually applied a kind of algorithmic thinking. You can see, for example, here a kind of detour, or should we go with NURBS or meshes? And so we decided to go with meshes, and then we really sketched. This is an original sketch from 2017. And so you can see the actual process. If you are into algorithmic modeling with Grasshopper, it's very easy to understand this kind of approach. So also the way we try to simplify the procedure is very important, because, you know, algorithms are kind of way to simplify process that totally meets the way our brain works. And so you can see the translation of a original sketch, and then we move to an algorithmic sketch, and then you can see here the actual translation into a Grasshopper algorithm that led us to the final shape. And moving to another scale, now this is a concept, it's not a project already built. we were talking about contamination. We were talking about how can we absorb different, like Imaginarium, different references. I always loved a movie by Federico Fellini, which is 8½, where a kind of spaceship is represented in the movies, a kind of mythological object that you can see in the movie. And I remember that I always thought about creating an object, an architectural piece that in a way was directly connected with this fascinating idea. And after a kind of nightmare that I had, the idea was to create a path between A and B using a cloud like a reference. So we called this project the Cloud Bridge. And the subtitle was the line is the most boring way between A and B. You know, in general, you see the line is the shortest path. In our idea, the line is the dullest path between 2 points. So the idea was to create a non-linear path between 2 points. So a kind of totally random, arbitrary shape. And then we develop an algorithm able to create a three-dimensional grid that actually was balancing the asymmetric loads coming from the particular path that you have, also giving a kind of new experience. You know, also the idea of experiencing the fear of being in a kind of incredible object, architectural object. And here you can see the main logic, a non-uniform, a non-linear path between 2 points and a grid automatically generated by the algorithm. The nice thing is that kind of, I don't know, 2 years later, more or less, we received a message from an important organization in Peru. And they said, why we don't do it for real? Why we don't, I don't know, try to understand if it's possible to create the bridge for real? And then we started a feasibility study. And it's incredible how a kind of nightmare you know, became another nightmare in terms of, you know, computational tools and FEM analysis. We worked with different like engineering study offices, and was really super valuable experience to understand how to, again, to translate a rough idea into something buildable. And so we create numerical modeling, and also we tested the seismic properties of a bridge like that. And now it's under development. I have to say that it's a very challenging project also in terms of funding. So the project is in a way is on hold right now, but we have a feasible study, and that's very, for us, was an incredible journey in order to understand how to really to create an unprecedented and unparalleled piece of architecture. News installation is, I was mentioning before, you can also see behind me, this is actually the first project that I created as a computational designer. It was a sculpture, so different scale. This is an art installation that we made within the Chiostro del Bramante, which is one of the most famous Renaissance buildings in Rome. The idea was to create an object that, in a way, that gathered and expresses the Renaissance idea of numbers into a physical object. So we started with the Fibonacci series with different mathematical proportions that we found within the Chiostro, and then we translated into a three-dimensional sculpture that was manufactured using like aluminum. They are, I don't remember now, but more or less like 200 panels of aluminum catted using water jet machine with more than 1,700, I remember that, connection they were made manually. So also the idea of merging together a kind of craftsmanship approach and the digital manufacturing ones. So everything connected together. As you can see here, the final model, the three-dimensional model and the actual one assembled in the cloister. And we also explore different ideas that was a kind of three-dimensional appearance when you were on the first level of the cloister, so you can perceive this kind of three-dimensional shape, but where you were in the ground floor, you could actually see the transparency. And also it was used as a stage for a dancing performance. And the object also materializes the idea of movement, this kind of rotation that is absolutely captured in the picture that you can see on the left side. And that was the first exploration in a way in the installation world. Then we collaborated with many artists and designers. This is a sculpture that we made at Victoria and Albert Museum in 2017. It was a collaboration with Ross Lovegrove. I know that it's difficult to understand how complex was to manufacture this object, which is an art installation within the tapestry gallery of the Victoria and Albert Museum. So we try to match the colors. Everything is created using Alcantara. The Alcantara is a kind of artificial leather material, totally ecologic. And then we try to match the colors that you can see in the tapestries. Everything was manufactured in Italy and then shipped to London. It was also difficult in a kind of, logistic way. And also the embroidery that you can see in the object was created with a CNC machine. So also the embroidery was made in a digital way. And I think that we spent more or less 6 months for manufacturing the whole project, as you can see here. And it was also a very playful piece of art. Was absolutely the guy, like kids enjoyed. There are a lot of pictures of people that actually lived and enjoyed this sculpture. Was a kind of please touch the object. And as you can see here, everything was created using kind of wooden structure. We have a kind of inner skeleton that was manufactured in Italy, as I mentioned before. And then we shipped everything to London from the Victoria and Albert Museum. This is a similar, in a way, installation made also, again, in Alcantara. Here we explore the possibilities of using mathematics, in particular, the knowledge connected with the Gaussian curvature, in order to create a three-dimensional sculpture using flat stripes. So with a super complex inner structure, actually, that is basically a building, because we are talking about more or less 30 meters by 4, something like that. So there is an inner structure. Everything created, all the connection that you can see with the algorithmic logic, and then a set of stripes that are planar and assembled in order to, again, creating the three-dimensionality using flat surfaces. This is a recent project developed by me together with the Design Morphine team, Michael Pryor and Paulina Vardulaki, with Matteo Silverio, which is an expert in glass manufacture. Is a very recent project that we developed for the Venice Glass Week in Venezia, Italy. This project combines you can see a video here. This project is called Horizon. It's a suspension lamp where we combine together 3D printing and also Venetian craftsmanship. So I was saying combining advanced 3D printing with the traditional Venice glass making, Venice, and in particular the city of Murano, which is famous all over the world for glass craftsmanship. And so the idea was creating a kind of hybrid object between high-tech and low-tech, where also imperfection was a value. And here you can see how we have a kind of inner shape 3D printed one with kind of advanced LED system inside. Here again, kind of early and primitive sketch that I've done in order to visualize the idea. And the complex part, as you can see, as you can imagine, was to have a kind of glass shelter that totally and perfectly fits the 3D printed part. So actually the process was creating the three-dimensional model of the inner part, which was 3D printed and was designed in order to have a kind of transparency in order to put the LED system inside. And also so that the three-dimensional part was was critical, but very difficult to design in order to like provide cavities and interstices for the LED system. As you can see here, with the we use one of the smallest LED system like available right now on the market. And I was saying the critical part was doing a kind of reverse engineering from that. So starting from the inner shape, we created like negative molds, and so the glass was molded using these kind of references by hands in Venice. And then you can see the final object that gathered together this idea of low-tech and high-tech combined together. Different scale and different industry. Also, automotive is like changing radically. The transportation design is like having a kind of new renaissance thanks to new technologies, but also the also new kind of engine. You know, there are two main revolutions that are, you know, self-driving cars. So the introduction of AI and the way car today are like they can drive by themselves automatically, and also new kind of engine, and so the electric powering. And these two main revolutions, they are also shaping the interior and exterior of cars. I also collaborated in a different project with many manufacturers. I cannot show you many interesting projects, but as you can imagine, they are protected by NDA. But this a collaboration with that I can show you actually with a company, a Chinese one, which is called Jack Motors. We started in late 2017 actually. This is a car called XEV. The idea of this car is first of all having an electric city car with a maximum speed of 70 kilometers per hour. So it's not super fast, of course, with a super simple structure and a body which is made by using more or less 53 elements for the body. And many of them, most of them are created by 3D printing technology, so additive manufacturing. So as you can see here, we developed specific algorithms in order to design the main parts of the body, but in specific details for the car, like innovative and in terms of aesthetics, three-dimensional patterns, also in order to provide customization for the final client. And the interesting part was using new details and unprecedented details for a small city car. as you can see all in the images. This is not just a prototype. This car is going into production, is already in production and will be on the market in a few weeks, I guess. And we studied different parts, as you can see in the images. We also try to push the boundaries using, this is a prototype, sorry, it's a concept that we developed for, we were invited by Volkswagen for this project. And actually the idea was using virtual reality to explore new ways for designing a car. So we explore and we combine together different softwares here. You can see Rhino or Grasshopper for the algorithmic part, but also Unreal Engine, which is a piece of software used for video games in general. So combining algorithmic modeling, virtual reality, and advanced rendering, because here we are talking about a real-time rendering, was absolutely incredible, because we were in two designers when we modeled this car, and it was unbelievable to have real-time rendering. So we were able to manipulate the shape using algorithmic modeling. You can see some sketches or some screenshots from the process. We actually had a kind of virtual tablet in the virtual world. So we were able to change different details and having a real-time rendering within the virtual world in a way. So imagine, for example, to be one designer is inside the car, another one is outside. And so you can coordinate this kind of modification, and it's a kind of absolutely novel way to explore different ways of think and model an object like a car. And so you can see the final renderings. I mean, everything was created in real time. That's the great part. We also used like advanced modeling tools. Like in this case, we used Houdini and Blender in order to, in a way, to fix the movement into a detail. So we use a kind of vertex simulation, and then we freeze the movement, and then we transfer this idea into a detail of the car that looks in movement also when the car is stopped. And this is the final object. That's interesting because Volkswagen organized this event in order to collect different ideas from designers all over the world. And we used a new platform, which is called MindDesk, in order to do that, which is a virtual reality system fully integrated with Rhino, and with the possibility of connecting it with other software like Unreal Engine, for example. And then we collaborated with many designers and companies in footwear. I will be just a quick presentation about that, but we started in 2015 with this concept that was translated into an actual product. They are called Ilabo shoes, designed in collaboration with Ross Lovegrove. It was 2015, and also the scenario in terms of tools was completely different from nowadays, and was really a challenging project to create a kind of single mesh, three-dimensional mesh that worked as an upper in order to compress the foot, and having a kind of totally new language, which started with the idea of gravitational hair, as we usually called at that time. Like you have parallel hair that are attracted by the foot, and then you freeze everything into a three-dimensional object. You can actually see the algorithm that we used at that time. And everything was created in a few weeks. It was absolutely one of the most challenging projects I worked on. And here you can see the final, it was manufactured, of course, using an SLS machine. And the same logic and the same actually collaboration was enhanced and with in different projects like this. This one is a fragrance bottle designed again in collaboration with Ross Lovegrove. It is on the market since I think October 2020. Here the idea of three-dimensional lattices using different materials. In the shoes we use basically powdered nylon solidified using an SLS machine. Here we used metals, also titanium. But the reference here is very important because this is a bottle, perfume bottle for F1, Formula One, and the idea is to translate the concept of a Formula One car where you have a skeleton, a steel skeleton, with the fragile part inside, which is the pilot in a car. And here we use the fragrance bottle, which is fragile because it's made by glass, which is inside. So it was very difficult to create a geometry allowing us to put the glass part inside the skeleton. And so you have in the same object an engineer technology and details, but in the same way you have this kind of expression of a metaphor, fragility inside this kind of metallic skeleton, and also translating into in a perfume bottle, you know. This is one of the first exploration, 2012. At that time was absolutely, now you know there are like we have plenty of tools allowing us to perform this kind of lattice structure. 2012 was absolutely difficult and was a way to use tools as again music producers or DJ use you know the console in order to mix different music genres together. And this is just a prototype, but was a proving ground for further exploration that we have done over the years. Here the main logic was the topology optimization. So the idea of starting from a kind of a black design space using just external forces in order to understand what's the best network that carries forces, and then we try to materialize them into a physical object. That was one of the first attempts in order to do that. And then I want to conclude with a joke in a way, with a slide. You can see algorithms everywhere. And mainly as a researcher and sometimes as a designer, people, they ask me, and I would say also students ask me, are algorithms necessary in design? And you know, this is a kind of question that nobody is like, I mean, nobody is wondering if algorithms are necessary in technology, in automotive, in every kind of field. And it's very curious that architecture is still wondering if algorithms are necessary in a way. And I guess that it is happening. This is happening because architecture and engineering, they separated like 100 years. There has a kind of humanistic profession, which is, it depends actually on there are several countries with different approaches, but basically I think that I strongly believe that architecture and engineering, they separated, there is this kind of split, and then architecture evolved like a kind of humanistic discipline. So that's why we are still wondering if it's important or not to integrate the algorithmic design. But also here you can see an Apple computer disassembled. Apple, for example, is using algorithms, but also AI and machine learning, also for distributing the components inside the case. So technology and companies today are using massively algorithms, machine learning, AI, or whatever, also just for placing components in the best possible way. And in architecture, we are creating tools for doing the same thing. If you just when we design a layout for a house or an hospital or offices, we are still doing that by hand. But we are plenty of tools that can improve and accelerate and facilitate also the design of house layout, for example. So to me, it's absolutely necessary to get into algorithms also in architecture. But there is something very important, and I want to summarize it with a simple sketch, a simple picture, an image, is that you can see this is an image from WALL-E, is a cartoon by Pixar. And there are two robots. You can see Eve on the left and WALL-E on the right side. And to me, they are describing two different eras and stages. On the right side, WALL-E looks like a kind of design where every part is shown off. It's like, the Centre Pompidou, the Beaubourg in Paris by Lorenzo Piano, where the technology was exhibited. And I think that also parametric design, algorithmic design, if you consider the buildings from Zadia the architects or Frank Gehry, they were showing off the complexity because was a kind of way to scream, to say loudly, we are showing complexity because we can do new things. We have new tools, new powerful tools, and we can hack, and we want to exhibit them. But I think that we are slowly moving towards Eve. I mean, we are going towards a new kind of complexity where actually the complexity is hidden. And you can see only the interface, which is absolutely simple, which is what is happening in the iPhone, for example, where we just have a kind of simple tablet, just a black interface where the complexity is inside, is hidden. And probably we will use algorithms not to create or to design intricate geometries, but also to simplify the architecture and design as interfaces. And I deeply believe that the next keyword for the future is the word interface. A couple of days ago, I have made my first lecture into a virtual space that was called Illusor. Was the first conference that happened in virtual reality. And I realized how interfaces are the next step for architecture. And I'm not talking just about VR or mixed reality, but we are in a particular stage of architecture where interfaces, are something that connect and disconnect in the same way. And I think that they will play a super important role, a critical role in the architecture and product design for the next years. So thank you so much for the attention. I really hope that you enjoyed this, this journey through different experiences that I've done in the last 10 years, more or less. I'm going to interrupt the sharing. Okay.
Thank you very much, Arturo. That was absolutely amazing. I would like to give the first word to Giancarlo, and we can continue with the questions after.
Thank you so much. We cannot hear you, Giancarlo.
Yeah. Okay, can you hear me?
Yeah.
Yes.
That works.
Okay, perfect. But actually, I'm forced to speak English because I cannot speak Italian and I cannot speak Spanish because Arturo is not going to understand me. But you have to learn, Arturo. So my question to you is, throughout all these path and all this journey that you had since the early years of let's call it parametric design, computational design. Yesterday there was this interesting speech by Yoshi, another friend, that was questioning these names, this necessity to give names to everything today. But anyway, call it parametric design, computational design, it doesn't matter. Throughout this journey, what has been the role of your particular training or education? You're an architect, so how do you feel your university studies introduced you to this kind of disciplines? Because I share with you the same Commodore 64. I share with you the same crazy, ideas of programming with BASIC. I also have an encyclopedia of BASIC that I still have it in a box together with the Commodore 64. So
amazing.
I was not a normal guy. I didn't play soccer, so
I did actually.
Yeah.
I did actually.
Not like you. I'm a weirdo. But anyway, how do you feel that your education introduced you to this kind of world, actually?
It's super. Thank you for this question, because probably nobody asked me something like that, and I would say that my education didn't prepare me for that, in the sense that I didn't receive any kind of skill or information in terms of algorithmic thinking, of course, because I studied architecture from 98 to 2005, 2004, more or less. And I know it sounds strange, but at the time, our professors, they didn't want to see a laptop in the class. I remember precisely, I studied in Naples, in the southern Italy, and they didn't want everything about that. So I remember I was really fascinated by their early works by Zaha Hadid, that at the time she won the Pritzker Prize in 2004, if I remember. So I was fascinated by her approach, and I didn't have the skills and tools for modeling, for imagining this kind of architecture. So in a way, my education was about disassembling the complexity. So I was forced to understand the complexity of design and architecture without having the tools for doing that. So in terms of skills, I didn't receive anything, but just because the professor, they were not prepared at that time, but as a reaction to that, I developed by myself. And it's important to say that all the Grasshopper community, let me talk about Grasshopper in general, the word of parametric design evolved also thanks to this tool. It's very important to say that. Was a kind of underground world, a kind of masonry in 2006, 2007, when Grasshopper world started. I met a lot of people in that underground world, so really like a kind of masonry and or secret society, But university really gave me this kind of, it forced me to think about how to disassemble things, how to understand things, and also was very important I really had a lot of time. Now, we are really, there is this kind of information overflow right now. When I was a student, we didn't have internet. I didn't have internet, at least. And so I had a lot of time to absorb everything. So, and this, in a way, it like gave me this kind of approach and attitude of a researcher, even if I'm not really a researcher, because I'm an independent one, actually. But for example, I started writing books in 2008, 2009, because really university taught me this kind of the need of like disassembling thing to to separate, to understand what's important, what is not important, to understand what's the focus and the kernel of every information. And so how to organize complexity into something easy to read, easy to share. And was also a reaction to that, in a way. I don't know if you share the same feeling, Giancarlo.
Yes, I studied, well, a few years before you. It was like the late 90s.
Yeah.
You see my white here that you don't have, actually.
No, I have it.
I truly am. Yeah, okay. I don't see it, but anyway, I believe you. But yeah, actually, it's quite interesting to me, this kind of old-fashioned approach, because I'm going to talk about this basically tomorrow in my speech here at the meeting. But I think you and I in some way we share the same let's say focus about the truly important things about digital design, parametric design, call it whatever, which is basically truly understanding geometry, truly understanding the basic of design. You know, how to translate an idea, a concept in something that you know, must occupy some physical space. So it becomes geometry somehow. So that's why I was curious about. You know, we studied different careers in different places, so I was interested in this kind of, you know, to share this kind of background. I was quite sure about the answer, but yeah.
There is also another thing. Yeah. There is also another thing that, in a way, I said during the speech, which is design studios, in particular, they gave me they consolidate the need for an architect or for a designer to develop a storytelling. So I was talking about, you know, the references, the Fontana paintings or Fellini movies or whatever, which is not just, you know, just to justify what you are doing. You know, you have an idea and you find a reference that make your design more solid in terms of story, you know. But actually, I really think that one of the differences of and this is a characteristic of the Italian design in general, is the storytelling behind a project. For example, I really admire designers like Fabio Novembre, who, if you check his projects, they're very different, but he used parametric tools, but not as an expert, let's say. But I always love the storytelling which is behind the project. And that's the difference between, I use the analogy, music engineer, music producer. This is something which is strictly connected, I think, with Italian attitude that starts with, you know, the Fiat 500 or the Mocha Bialetti, you know, the coffee machine. It's, our design is a kind of anthropomorphic. There is always also a kind of funny attitude behind the object that we design, mainly in the industrial design. For example, we have companies like Alessi or Cartel that are famous all over the world. There is always a storytelling behind it, and I see a lack of storytelling nowadays in the 90% of the so-called parametric design. But I was showing, you know, also the difference between Eve and Wally. I think this is just the first stage, the early stage, where we use computational tools to show the mass holes, you know, in order to say we can do all this intricate complexity. We can put together different tools or animation system or whatever. We can show the mass holes. But that's only the first stage, and I'm sure that we are going towards something more sophisticated, more subtle, through a pure digital era, and where algorithms will be really embedded in our design.
Thank you. We have Giancarlo's workshop starting at 11. So I think we're going to have just 2 more questions.
Yeah.
And that's it. So we have another question here from Jair Vega. You want to take the microphone? Jair? Okay, so I'm going to read it. Arturo, congrats for all your work. It's amazing. I would like to ask you, working in so many industries, what has been one of the biggest challenges and how much does art influence your work and computational design?
Well, the tricky part is that I'm an architect. So when your brain is educated with the architectural skill, it's very difficult to scale down. You know, it's very difficult to do. When I remember the first time I was working in a small scale, I didn't have the ability to control the details. In general, you know, also in terms of when you open a Rhino session and you set the scale and you set millimeters and you have a tolerance about, you know, 0.1 millimeters, everything changes. And so this is very trivial to say. I mean, when the scale changes also, you need to have a kind of different sensibility. But the most important thing to say is like you learn something when you fluidify, when you move from the small scale to the big scale, you learn something from the specific field and then you transfer it to the other one. Let me explain something. I'm sure that there are a lot of details today in automotive, and they come from architecture. I remember like when automotive started becoming, in terms of language, fluid and seamless. And of course, it's a matter of technology. You know, the automotive and transportation technology is improving, manufacturing, whatever. But you know, there is always a change in the language before a company can use it in a car, for example. You know, there are, when you develop a car, there are more or less 6-7 years of development. So companies are very safe and super careful when they design a car. And I remember the moment where cars started using a kind of seamless complexity that absolutely was coming from the architecture. And I showed you the use of patterns, for example, in a kind of aesthetic way for automotive right now. If you take a look to the new cars from Volkswagen but also Ferrari and the design by Pininfarina, which is one of the most famous automotive designers in Italy, they are using they're using like language science and languages that comes from architecture. And it also happens because designers are like multidisciplinary, because it's very easy today to switch from a car to a building or whatever. So there's a kind of hybridation that you use when you change scale. So in general, one thing that I always done is like using the seamless precision of products. I always try to translate into architecture, and I always try to put in products the power that buildings have. And in general, you know, when you are dealing with products like a mouse, let's say, or I don't know, or a car or a shoe, the expressivity that you have in buildings, sometimes I always try to translate into products. So it's important to do this kind of mixed hybridation between them, which is not easy, of course. But it's and I think that in general, designers, they are not prepared for doing that. You know, this kind of switching from a word to another. We are still trapped into academic watertight rooms, you know. where a designer should design products and architects should do buildings and whatever.
Thank you. I think we're going to have just one more question from Monica Vasquez.
Yeah, sorry, Giancarlo, if I'm stealing your time.
No, it's a separate meeting, so I have to leave right now. So
okay.
I wanted to say bye to you. So talk on the phone.
Speak soon. Speak soon.
Yeah, speak soon. And yeah, have a nice question and answer session. So see you again. Bye, everybody. Thank you for having me.
Enjoy the webinar. The tutorial.
Thank you. Bye.
Thank you. Hi. Well, Italian design has historically been synonym of beauty. You clearly have those genes within you. You said once, and I've heard in a lecture, that you find beauty through technology. And it's amazing how you merge this craftsmanship, like in the horizontal lamp, with high-tech manufacture and other disciplines. But what do you think, or what would you recommend to architecture or design students to not to lose that artistic feeling? You hand sketch a lot, and sometimes I think it's the missing part in the process in computer design. So I don't know if you have some recommendation for students.
Well, thanks for the question, because I think it's very important. And I think when we started to design the lamp, we said something. The lamp was designed by me and other two guys, and we said, I think that designers are scared of imperfections. In general, disaffection to objects is in parallel with perfection. Sorry for the, maybe it's difficult to understand, but you know, if you consider a phone like this, an iPhone or a smartphone, they are so perfect. And you have a kind of disaffection, you know, 2 years and you get rid of it. It's not valuable at all, because probably it's too perfect. There are few objects out there that in a way they are of value. They can be inherited by our sons or so on. And that's because we don't have anymore a kind of control imperfections into objects. So imperfection comes from hands. And so it doesn't mean that you have to create an object that doesn't work or has a lack of, you know, that cracks in your hands when you buy it, when you use it. But it's important to design processes that already puts the human being at center. Of course, it's still using digital technologies. So our idea was, we can create a lamp which is manufactured in Venice. And as you can imagine, it's not easy to go to craftsmanship and you say, we want to change your process. It's not possible to do that. No one will work with you if you say something like that. So we said something different. You will work in the same way, but we will support your process with digital manufacture tools. So we create molds that they were, of course, manufactured by CNC, computer numerical control, you know, based. And we didn't change their process, but of course the output was completely different. Because in general, if you go there in Venice, you can see the same design, the same objects made by glass. With this kind of approach, we got a kind of contemporary design. If you see the horizon lamp, the glass part, they look like, I call them Pringles, like the chips, you know, like the Pringles shape. And the glass is like something like 0.2 millimeters. It's something amazing, you know, fragile but precious, you know. And if you manufacture 2 or 3 or 10 lamps, they are different one from each other. But in the same way, you have an object which looks perfect and imperfect in the same way, low tech and high tech. So how you achieve this kind of result? Basically, when you put human beings at the center of your process. So it's not about technology for the sake of technology, but you use technology in order to also improve the output from hands. You also mentioned the importance of hand sketching. Well, you know, sketching is like the most direct way to translate ideas. You know, it's a connection between brain and a piece of paper, which doesn't have any kind of mediation. You don't have any kind of system that slows down the process that leads to a new ideas in a way, a new idea in a way. I see, I'm also a professor, I taught on many universities, and I always see this kind of urge from students to directly, you know, run the PC and running Grasshopper or Rhino, and sometimes they ask me, what's the best Grasshopper component to do that, or what's the best tool for organizing spaces? It's not only about tools, it's about to solve the complexity in our minds, and then the computer is just a way to accelerate the process, more or less. So it's important to embrace again, you know, this idea of having still a relationship with the paper, which is a relationship with our ideas, with our, we need to slow down a bit in order to improve the output. And but you need to educate students since the beginning, and this kind of, you know, it's always about low tech and high tech to me.
Thank you.
Thank you so much. Super clear.
Okay, we have some other questions since Giancarlo left for his, I think, I don't know if you have enough time, Arturo, to take a few more.
Yeah, of course.
So we'll continue. We have some other questions in the streaming at Facebook, so I'm gonna go ahead and read one.
You can read it, so.
Yes. Okay, Elizabeth Frias says, what has been the most challenging project you have ever worked on in which you had to use parametric design?
I showed you is the iLab shoes, no doubt, was one of the most complex projects because it was like an architecture in terms of complexity, because if you analyze the project, it has so many layers. You have the upper, which is made by vertical hairs, and then we have a kind of hexagon inner grid in order to keep all the things together. And then we have the heel part with a lot of subsystems, and then everything was glued together. And so it has a kind of building complexity of an architecture, but it was is an object that you wear. So it's a shoe, and so the object is not symmetric. It should fit perfectly the human body, you know. And so you have you in a way, on one hand you have the precision, on the other hand you have this shape with perfectly meets and fits the human part. And I think that a designer, or that comes from architecture, like I am, was absolutely tricky to understand and to deeply control. In a way, a design which is precise but completely organic. If you also consider that we had a few weeks for doing the process, it was a moment in terms of tools evolution where creating a three-dimensional mesh like that was not easy at all. Blending together different meshes or different geometries in terms, of digital modeling was absolutely tricky in 2014-15, was absolutely complex. And I learned a lot from that project. We made a lot of mistakes and errors. I mean, I remember that the first design didn't work in terms of printing, not because because the geometries, they were not connected in a proper way. It doesn't mean that we were not able to do a 3D modeling, but you know, again, it's a question, it's a matter of scale. Probably that geometry would have worked for a building or for another kind of scale, but was completely different from a shoe. And then we learned a lot from trials and errors, you know. But absolutely was the most complex project.
Okay, thank you very much. We have another question here in the meeting. So, yeah. Rafael, you want to turn on your microphone? Okay, I think I'm going to read it. It says, sometimes, especially with parametric tools technology, not the designers end up controlling the final design. How do you avoid this from happening?
Well, you know, this is, it's a common question because over the centuries, architecture was a complex art made using simple tools, you know, just paper and pencil for centuries. I know it's strange, but if you focus on that, we are not prepared for the introduction of a massive use of the computer in architecture. So this question happens because for centuries, architects, designers, artists, they just used paper and pencil. Actually, for architecture is even more complex because architects, they don't make buildings, they make drawings of buildings, you know. Sometimes we never touch the matter, you know. So I think that we are not prepared for a change of paradigm where we don't use anymore a simple tool like this, but we have a system which is super complex, you know. We don't have it's not just a pencil. When somebody says algorithmic tools are just tools, I don't think so. They are more like a system. You need to totally control this system if you want to use it. And I think that sometimes, or when you start learning computational tools like Grasshopper or whatever, you feel trapped into a complex system, and so maybe the output is not deeply controlled. It's like playing a guitar, you know. At the beginning, you just produce noise. Maybe if you have, mainly if you have an electric guitar, you plug it into the amplificator, you just play something, and you know, the electricity, the amplification produces some noise or sounds or something like that, and you say, okay, I'm doing something is not deeply controlled. Of course, you need to study, you need to become a master in the instruments, and then you can express yourself through the instruments, through the tool. So in general, I don't think so. I don't think that the output is not controlled. Even if in the most advanced application like generative design or AI, you have some control. Just there is a branch of technology which is called GAN styling, or GAN is a branch of machine learning. Probably only in that field you don't have a deeply control of the output because the system is structured in that way. But in parametric design, to be specific, using Rhino, Grasshopper, or algorithmic modeling in general, you can fully control the result. It's just about, it's a matter of understand. It's about the level of understanding of theory, tools, and systems.
Thank you very much. I have a question myself.
Yeah.
This event is for young architecture students who doesn't have heard before about these tools, about these technologies. So thanks again. This is a wonderful example of what we can reach. And I would like to know what kind of advice or what can you say to those young young computational new designers?
Future computational designers.
Yeah. What would you tell to them? What kind of advice?
Yeah, I won't suggest webinars or tutorials or YouTube or books or whatever. I think it's important to, I think that maybe I already gave you an answer when where I said that basically architecture switched from the pencil paper approach to something which is really more complex. And again, the algorithmic approach, the algorithmic thinking is absolutely mandatory today. So the suggestion is like starting thinking in an algorithmic way. If you are designing the layout for a room, nowadays we have many processes, procedures, tools, of course, in order to improve the way we design. And it's not only about, you know, guys, to save space or to optimize the space, but again, can be, I don't know, I can improve, I can, design the layout in order to have a specific point of view, or receiving more sunlight, or I don't know, playing with the sound. Sometimes, I mean, one of the most important challenges for architecture is like manipulating the not measurable data. It's not only about dimensions, but it's about quality. That's the next challenge to me. But in a way, you don't have just your experience, your ideas, your vision, your references, and just a pencil and a piece of paper. You have a wide set of tools, and if you don't know them, ask other students or professors, or you know, you can contact everyone nowadays through social media. It's very simple, and that's the way to, you know, to face the new challenges of architecture. You should be very open, because tools are evolving very quickly. I can see different, I don't know to say, directions, algorithmic design, which is absolutely mandatory to me, which is the first stage. Then we have the generative design, which is something more complex, which is the idea of, there are many misunderstandings on these words actually in these definitions, but generative design is like the idea of creating DNA. I mean, instead of assembling architecture, you know, slabs, walls, pillars, and everything organized, adding piece by piece, you can actually create a DNA. We have done something like that, for example, for a chair, which I didn't show in the presentation. I mean, you can really grow a geometry by creating a DNA. So the chair starts from a voxel, which is a three-dimensional pixel, you know, it's like an atom. And then it grows according to structural rules or ergonomic ones. And then you have the final shape, which is breed. You breed geometries, you grow geometries. They are not created by adding one piece on top of the other. And that's a very important direction. And then we have all the world of AI, which is evolving with a speed which is absolutely amazing. And it is evolving in parallel with the technology. For example, NVIDIA is playing an important role on that. And I'm absolutely, I think I'm sure that AI will be a kind of new technology for improving architecture. And it's like having you know, thousands of data about different again layouts, and through this kind of comparison using neural networks, you can get the best solution for a specific problem, which is not made in terms of geometry, you know, it's not like about a relationship between geometries, but a kind of recognition, which is similar to the way our brain connect things together. And I think that you should, as a young students and then professional, you should be prepared to a new kind of collaborative world where architect is a part of a system, of a team where different disciplines work together, like neuroscience, like, you know, advanced computing, or, you know, I don't think we can still think to architecture like just a humanistic like profession. You know, it's not only about style, it's not only about playing with proportions, you know, but it's about and you know, we are in a very important stage of human evolution. We are discovering which is possible to work and to work from our houses, for example. The pandemic is teaching us that different solutions are possible. We can imagine new spaces, you know, and new spaces is not only about creating a nice background where we are on Zoom or Skype or whatever. We can probably and we will be forced to reimagine new spaces with a kind of hybridation between work and domestic dimension, you know, private and public. I guess that it's very important to redefine them, because we are in a kind of, you know, new adaptation in the history of human beings for the first time, and we have the technology, and also the virtual spaces, VR is giving many possibilities. And so you should be very open to you should embrace technology and able to open to a dialogue with different professionals and different expertise.
Thank you very much. Okay, let me see if we have any other question. Okay, here we don't have any other question. On Facebook, Paola says, what books do you recommend us for computational design?
Well, everything, as I said before, there are several layers and dimensions. So I would say every book which is about geometry is the first step, because even if you are creating platonic and simple geometries or advanced shapes, geometry is the every time and always will be the first stage. So geometry is the first step, of course. But I also recommend to read everything which is about the digital evolution in general. I don't know, it will be very trivial, but everything which is not only about tools, but about books are a window to different experiences, you know, and today it's very easy to access them. So as I said before, I won't mention and recommend books about Grasshopper or Rhino or whatever. There are plenty of that. You can, I also showed you mine, you know, but it's not only about that. You should be really prepared and aware about what is happening right now in the world of design. So everything which is about the digital revolution, I think it's important, because you are young students or young professionals. So it's important to create a solid background and a solid structure. And then you can, you know, it's a kind of bookshelf. You have to create the structure, and then you can put inside every kind of book, which is more specific, you know. So I know it's a non-answer, but I won't suggest book on Rhino and Grasshopper. It's important. In general, the digital revolution in architecture and design, that will be very important. And also, you know, also the monography about single designers. Sometimes they also show us the also the experiences of other designers and where we are going toward.
Thank you. I think we have one last question. Jairo Vives says, question for Arturo. On terms of space making, how do you see technology becoming a catalyst for human relations and interactions with a tangible experience?
It's a new field to me. As I said before, the next challenge is playing with not measurable data. You know, it's very easy today to play with height and length and width and whatever. It's not about that. I think that we really need to explore the invisible dimension of space, mainly in an age like this one, where we are experiencing isolation. And I'm sure that we have this kind of human needs to stay together, to stay connected. Or I have to say that I didn't see any projects which actually is like trying to explore, or I see few of them that they really try to reimagine the way we stay together. I mean, we have, as I said before, public, private, workspace and domestic space. Probably everything will be reconsidered, and of course tools they play an important role. I think AI, again, machine learning. I know that when I say AI, you will probably think, I don't know, you imagine robots that try to kill people. It's not about that. AI is something super simple, actually, because like you don't need to become an expert in neuroscience. There are a lot of tools available out there for free, and then you can do exploration with AI by yourself without any investment in terms of technology or software. It's a bit like Grasshopper. You don't need to have to be an expert in coding. You can just open Grasshopper within Rhino. You play with boxes, with components, and then you create your own tool. So I guess that AI, machine learning, and optimization tools in general, they will be a kind of propeller, is a driver in order to create a new kind of space. I don't have an answer, of course. It's not easy to give you simple answers, but of course it won't take birth using pencil and papers again, but it's important to, but again, the solution is into the invisible and not measurable data. That's it. The quality of space that comes from something which you cannot translate into numbers, let's say.
Thank you. Okay, so I think we don't have any other question. Oh yeah, we have one last one.
Okay.
Olufemi Obudunurin, sorry if I mispronounced it. He says, where do we start to reach your level?
I think it's very easy right now. When I started in 2008. The world was completely different. You know, it's crazy. It's like 10 years ago, more or less, 12 years ago. And we spent, I say we, because I also consider guys like Giancarlo or other people that started in the same period. We didn't have any book at the time, or internet was different from today. Instagram, I think, was not out there in 2008, if I remember. Facebook was a kind of novel thing, so was absolutely not. What was absolutely difficult at that time to also the access to information. Today, you don't have any kind of excuse. Let's say everything is online. You just need to have a precise. You need to focus on a precise goal, because you can really access to every kind of information today. It's just about creating a kind of structure, and it's about goals, about specific tasks and direction. And it's difficult to say you just need 2 years or 3 years or whatever, but absolutely it's not about 10 years right now. It's not. It's a matter of of just having a precise direction. And as I said before, tools are a part of the learning path. It's important to have a clear idea of what you want to become, and be just aware of that. But it's absolutely easier today compared to 10 years ago, let's say.
Thank you. Okay, I guess that with this answer, we'll conclude this session. Thank you very much, Arturo. It has been a...
Thanks to you guys for having me today. Great pleasure. And I hope to meet you soon, maybe in person. And okay, so good luck to all the students, all the people that are connected with us today.
Thank you very much. And yeah, we hope to see you probably here in Mexico. That would be awesome. So thank you very much, Arturo.
Have a good day.
Bye to everyone. We're going to have Rolling Snooks and another sessions later on the afternoon. So please join us later. Ok, sería todo por hoy. Bueno, por ahora, nos vemos más tarde. Gracias a todos. Hasta luego.